Polar coordinates are an alternative system to our familiar Cartesian coordinates. They are measured using a distance from the origin and an angle.
The orange point is 2 units from the origin at an angle of 45 degrees. The blue point is 4 units from the origin at an angle of 185 degrees.
It is often useful to switch between polar and Cartesian coordinates, and for this we need some equations. One of them will look familiar as Pythagoras' theorem. The other two are easily derived from our trigonometric SOHCAHTOA equations.
First, we calculate the radius using Pythagoras' theorem. Then we rearrange the equation defining x to give us theta.
Some curves are more easily defined using polar equations. This is the Archimedean spiral given by the equation r equals 0.1 theta. This is the polar rose given by the equation r equals cos 4 theta. And this curve is called the conchoid and has the equation r equals 3 plus sec theta. Some curves like these are ugly or even impossible to be defined with Cartesian equations.
Cylindrical coordinates are a three-dimensional extension of polar coordinates. You first find the projection of your point in the polar xy plane, and then count how far up you need to go. Spherical coordinates are an alternative three-dimensional extension of polar coordinates. You first find the distance from the origin, then the angle in the xy plane, and then the angle above or below the xy plane.